Hello and welcome to my YouTube channel. Today we will discuss about the Earth, how the Earth is and how it's look like, how it is revolving around the Sun, and what's its internal features and how it's look like. Then we will going in detail in depth the Earth. Internal structure, but let me introduce a little bit introduction about the Earth and its main features and properties. So you can see here that this is Mercury, Venus, and Earth. So introduction, we say the Earth is the third planet from the Sun and our solar system. Very basic properties it is that the third position, the Earth is revolving around the Sun. If we have Mercury, then we have Venus, and then we have the Earth, and it is the planet we evolve on, and the only planet in our solar system that is known to support life. That is one of the major property of the Earth, but the only planet where the life is exist. And why the life is exist, we will discover it later on. Okay, what are the size of this planet? So the most important thing that is how who can discover how much bigger, how much smaller the Earth is. The Earth is about 7,926 miles in diameter, 12,756 kilometers. The Moon's diameter is 27% of the diameter of the Earth. So this is a very smaller diameter moon revolving around the Earth. 3,476 kilometer of the moon's diameter. So the Earth is about that much of diameter. The Earth is the fifth largest planet in our solar system after the Jupiter, Saturn, and Uranus and Neptune. These are the largest planets in the solar system. This man. Eratosthenes was a Greek scholar in 276 and 194 BC, who was the first person to determine the circumference of the Earth. He compared what the procedure he used. He composed the midsummer's noon shadow and deep wells in Sani and Alexandria. He probably assumed that the sun's rays are vertically parallel. Since the sun is so far away, this is the particular procedure he used at that time. Knowing the distance between the two locations, he calculated the circumference of the Earth stadia. So this is particularly the unit. Exactly how long a stadia is unknown, so this accuracy is uncertain. But he was very close. He also accurately measured the tilt of the Earth axis and the distance to the Sun and Moon at that particular time. He used certain parameters to address these things. So this is a little bit about the history of that thing that's going on and back in the history. And the moon, what we talk about is 27% of the diameter of the Earth, 3,426 kilometer is the diameter of the moon. The Earth has one moon. The diameter of the moon is about 1/4 of the diameter of the Earth. That is, we discussed all that. This was the picture or the photos taken by the NASA Galileo mission in 1990. You can see the moon here and the Earth and the shadow falling the Earth. Okay, the moon may have once been a part of the Earth. It was a theory, but let me say it may be true, it may be wrong, but it may have being broken at Earth during an catastrophic collision of a huge body with the Earth billions of years ago. About the mass, density, and escape velocity of the particular planet Earth. So, what is the mass of the Earth? What is the density, and how can you escape the Earth's gravitational force? by by finding. So the mass of the Earth is 5.98 multiplied by 10 raised to the power 26 kilogram. This is the mass. The Earth has an average density is 5,520 kilogram per meter cube. Water has a density of comparatively 1027 kilogram per meter cube. Earth has the densest planet on our solar system. This is one of the most important thing that even the Earth is the fifth largest planet. Even the Earth have exist life and it contain the water. The water make it is capable that exists the life on the Earth. So this is a very important concept. To escape the Earth's gravitational pull, an object must reach a velocity of 24,840 miles per hour. Length of a day and year on Earth. Okay, so a length of the day. What is the length of the day and what is the length of the year? Each day Earth takes roundabout 23.93 hours. Take it is around about this much time to rotate around its axis once. Even you can see here, if we can take this, and we say little, we reduce the thickness and we take this. So this rotation is taking from this particular point and it rotates around itself and it's come back into this particular position from where its initiation, its rotation. This much time is required to rotate around itself. This is a sidereal day. Once it rotates, it's complete one full rotation. It's called a sidereal day. Each year in Earth take round about 356.26 Earth days, sidereal days. That is, it takes the Earth to 365.26 days to orbit around the Sun. If this is the Sun, so it's take around about 365 days to complete its one revolution around the Sun. The Earth rotation is slowing down very slightly over time. Another property of the Earth is Earth orbit. On average, the Earth orbit is 93 million miles from the Sun. So this is a huge amount of distance. This distance is defined as in one astronomical unit. The Earth is closest to the Sun. This is called perihelion. If it is closest to the Sun, then we call it is perihelion. When it is farthest away from the Sun, then another terminology used here is aphelion. And the Milankovitch cycle, where the Earth is closest to the Sun, then it have a greater chances to takes more energy from the Sun and increasing the temperature of the Earth. But if it is far away, it is aphelion, then it is probably take very much lesser amount of the energy from the Sun. Then the Milankovitch cycle explained that the orbit away from the Sun, then we most probably get very lowest energy. So this is a property, and when it is closest to the Sun, so it is round about 2 January each year. each year to January, it is the closest to the sun. And when it is far away from the sun, it is again around 2 July. You can keep these in mind. Every year, 2 July, the Earth is very far away from the Sun. Every 2 January, the Earth is closest to the Sun. And what the terminology used here? Perihelion and ephelion. Demonstrating in that particular picture, if it is away from the Sun, a very when it is close away from the sun, it is 2 July, and each year 2 July, it is away from the sun, and it is called the Milankovitch cycle. The sun and earth are not to scale in that drawing, but it is just only to understand. The graphics will only for to understand and visually understand those particular discussion what we doing. Okay, so orbital eccentricity. The Earth has an orbit that is close to being circular. Not particularly circular, but it is close to circular. Its orbital eccentricity is around about 0.017. So this is the eccentricity of the Earth orbital. Eccentricity is measure of how an orbital deviated from a circular. What does it mean? Simple words, the eccentricity of a circle is zero. If orbital is particularly circular, its eccentricity is zero. But if it's not particularly circular, then we say its eccentricity is deviated. Its circularity is deviated. So if it is deviated from a circular orbital, it is more circular. It's have a very low eccentricity, and it's maybe zero if it is particularly perfectly circular. An eccentricity between 0 and 10 representing elliptical orbital. What is the then the concept is very clear. If eccentricity is zero, it means that it is particularly very well circular orbital. If it is one, then we say it is elliptical. Okay, the Earth exists at tilt from perpendicular to the plane of the elliptical by around about 23.85%. This tilt is what gives us the pole season of the year. If the Earth is tilt, you can see here. Okay, it's not particularly. I draw a perpendicular line, but you can consider it as a perpendicular line. So this tilt from this position, this tilt and this angle is around about 23.45 degree. The tilt and the particular angle is this much amount. This tilt is what gives us the four seasons of the year: summer, spring, winter, and autumn. Since the axis is tilt, different part of the globe are oriented toward the sun at different times of the year. This aspect, the amount of the sunlight each receives, speed at have to rotate. At the equator, the Earth's surface moves around about 40,000 kilometers in 24 hours. Every rotation have the highest speed in the equatorial region. This is the equatorial part, and when it's rotating, when the Earth is rotating, the equatorial speed is in 24 hours. At the equator, the Earth's surface moves around about 40,000 kilometers in 24 hours. This is the rotation speed at the equatorial region. That is equator, and that is pole, north pole, and south pole. The speed of the equatorial motion or rotation is 24 hours. It's calculated by dividing the circumference of the Earth at the equator by number of hours. As you move towards the either poles, the speed decrease to almost zero, since the circumference at the extreme latitude approaches to zero. The Earth revolving around the Sun at a speed of about 30 kilometers per second. This comprises with the Earth's rotational speed of approximately 0.5 kilometer per second at middle latitude near the equator region. Now, what about the temperature? That is the most important aspect and the most important properties of the Earth. Temperature on the Earth ranges between minus 127 Fahrenheit to 136 Fahrenheit, and we can take it is into centigrade and then Kelvin, so can convert that. But minus 127 Fahrenheit to 136 Fahrenheit. The coolest recorded temperature was on continent of Antarctica, and that was that particular location, and that is the time, and that is the year where the coolest temperature is recorded, and the hottest recorded temperature was on the continent of Africa, and that is Libya and September 1922. So, okay, if you can see here, what we say, let's discussing about the greenhouse effect. The sun radiation is directed at the Earth's surface. When it hit the surface, some of that radiation is absorbed into the Earth body, and some of that is reflected back into the atmosphere. That reflected part, only a few percent of that is again reflected from the greenhouse gases. The greenhouse gases is similarly act as a black body, as the Earth act as a black body. It absorbs some of that energy and reflect back some of that energy going down into the Earth, and some of that radiation is going back into the atmosphere. We don't have a concern that the radiation reflected back into the atmosphere, out of the atmosphere uh, into the space. But we have concern that the only little percentage of that reflected back into the earth, they can actually heat of the earth. That is the phenomena of global warming that is related to the climate changes, increasing of that particular temperature that can cause the global warming and climate change. Okay, so uh, the greenhouse effect trapped heat in our atmosphere. The atmosphere lets some infrared radiation escape into the space, and some is reflected back into the planet. That is already discussed and that figure. Okay. Another thing that is atmosphere. Atmosphere of the Earth contains certain uh, exosphere, ionosphere, mesosphere, stratosphere, and troposphere. These are the different layer and the atmosphere that are there. So the atmosphere is a thin layer of gases that are surrounding the Earth. It is composed of 27% of nitrogen, 21% of oxygen, and then we have argon and 0.9% and 0.03% of carbon dioxide, and trace amount of other gases is also exists in that atmosphere. The atmosphere was formed by planetary degassing processes, in which gas like carbon dioxide, water vapor, sulfur dioxide, and nitrogen were released from the interior of the Earth due to volcanism and different tectonic activity and other processes like life form on the Earth have modified and composed of atmospheres and their evolution. So, in evolution, the atmosphere play a crucial role. Initially, we have a life that is required no oxygen, pre-oxygen in the atmosphere. Then we have the evolution that increase this value of oxygen, which is very much important for living organism, that for respiration. So this is the evolutionary stages where the Earth is coming out of that. Thank you so much, and don't forget to subscribe my channel. If any queries, any information you need, you can contact with me below and to the comment section.